Let's take a look at how we set up acceleration problems. So in this problem, a rocket is traveling upwards at a velocity of 413 kilometers per hour. At event 1, its engines cut off. It begins to slow down at a rate of negative 13.7 meters per second squared. At event 2, it reaches its highest point. And we want to know how much time it takes to reach the highest point. So let's set that up in part A of our solution process. We want to start with a sketch showing the events. So the rocket is traveling upwards. So maybe at some point in time it was down here on the Earth. And then at event 1, it has this upwards velocity of 413 kilometers per hour. So I'm going to choose a coordinate system where upwards is the positive y direction. And here we have event 1. And at event 1, the engine cuts off. The rocket continues to travel upwards. It's moving very quickly, and it takes a while for it to slow down. So later on, it reaches a higher position. And so this is event 2. So we now have a sketch showing the two events. We've described the events, and we've given our coordinate system. Good. Now we have to label the givens and unknowns with symbols. So it's moving upwards with a velocity of 413 kilometers per hour. So that's its velocity right at event 1. We're not interested in what happened before event 1. So we'll label that V1, and that's a velocity in the upwards or the positive y direction. So we'll write positive 413 kilometers per hour. Good. Now, in between these two events, it's slowing down at a rate of 13.7, negative 13.7. So that's the acceleration, negative 13.7 meters per second squared. So notice that I wrote the velocity attached to this picture here, and the acceleration is in between these two events. At event 2, it reaches its highest point. Here we have to use a piece of our understanding of this situation. We haven't been told it, but at its highest point, we should be able to figure out something about its velocity. As it's traveling upwards, we understand it's slowing down. And because of that, at its highest point, its velocity, so v2, is going to be equal to 0. So when we set up acceleration problems, there's some times where we have to figure out from the situation a velocity value or an additional piece of information. So now we have our givens, and we need to identify the unknown. We want to figure out how much time it will take to reach its highest point. So the amount of time, delta t, is the unknown. So I'm writing that in between the two events. Let's see how we're doing. Unknowns, symbols in place, and now conversions. So let's check our units. For our distance units, we have meters and kilometers. So we'll need a conversion there. For our time units, we have seconds and hours. We'll need a conversion there. The question is, what quantity should we convert? Should we change the velocity to meters and seconds, or should we change the acceleration to kilometers and hours? The acceleration actually has 3 units, meters divided by seconds times seconds. This would require 3 conversion ratios to complete. For that reason, accelerations are very tricky to convert. It's seldom a good idea to convert the acceleration value. It's almost always better to convert the other quantities. So let's do that here. We'll set up our conversion ratio. We have kilometers in the numerator, so we have to put kilometers in the denominator of the ratio. So 1,000 meters is equal to 1 kilometer. The kilometers and the kilometers will divide away and give 1. Here we have hours in the denominator, so we need hours in the numerator here. So those will divide away. And 1 hour is equal to 3,600 seconds. So now we're ready to do our calculation. We have 413 times 1,000 divided by 3,600. Here we have our result in meters per second. We're going to keep 4 significant digits and cut off the remainder. The remaining units, meters divided by seconds. And now we've completed part A of the problem. Often, part A is the most challenging part of the problem. We have to make sure that our units work out, that we've found any missing pieces of information, and that we've been really careful if the directions of any of the vectors are different. So we might have some negative quantities. Setting up part A is super important to do carefully.